Critical numbers are values of x where the derivative is 0 or where the derivative does not exist. On our domain, in this case, where it's understood that x is from -2 to 2, the derivative is always going to exist. So let's find the derivative, set it equal to 0, and solve for x. So q prime. Again, what we have is 12x times the square root of 1 minus x squared over 4. So we're going to use the product rule. So q prime is the derivative of 12x times the square root of 1 minus x squared over 4 plus 12x times the derivative of the square root of 1 minus x squared over 4. The derivative of 12x is 12. So I have now 12 times the square root of 1 minus x squared over 4 and then plus 12x times the derivative of the square root of 1 minus x squared over 4. So we're going to use the chain rule. Remember, the derivative of the square root function is 1 over 2 times the square root. So in the denominator here I have 2 times the square root of 1 minus x squared over 4. And the derivative of the inside is going to be negative 2x over 4, which is the same as negative 1/2 x. So we're going to simplify. Q prime is 12 times the derivative, 12 times the square root of 1 minus x squared over 4 minus 12 over 2 is 6, half of 6 is 3. There's a negative sign here, so what it is actually negative 3x squared over the square root of 1 minus x squared over 4. So we have the derivative. We've simplified a little bit, but we're actually not done simplifying. What we have to do is get a common denominator. The common denominator happens to be the square root of 1 minus x squared over 4. So what I have to do is, on this term here, I have to multiply and divide by the square root of 1 minus x squared over 4. So what I will have is this: q prime is 12 times the quantity 1 minus x squared over 4 minus 3x squared. All of this is over the square root of 1 minus x squared over 4. So what I'm concerned with is, values of x where the derivative is equal to 0. So I have to distribute and combine like terms. So if you do that, you end up with 12 minus 6x squared. And again, the denominator is still the square root of 1 minus x squared over 4. So if q prime is equal to 0, whenever this numerator is equal to 0, so 12 minus 6x squared is equal to 0. This is where we are right now. This implies that x squared is equal to 2, so using the square root property, x is equal to plus or minus the square root of 2, but again, in our formula for area, recall area is equal to 4xy. So we want the area to be positive. Okay, so x is equal to the square root of 2. And then if that's the case, we can find y. Recall that y is 3 times the square root of 1 minus x squared over 4. But if x is equal to the square root of 2, x squared is 2. 2/4 is 1/2. 1 minus a half is a half. So that tells us that y is equal to 3 times the square root of 1/2, which if you rationalize, we get y is equal to 3 times the square root of 2 over 2. So we're getting there, we're very close. Remember, the directions were to find the area of the largest rectangle, so we're very close. So area is 4 times x, which is the square root of 2, times y, which is 3 times the square root of 2 over 2. So the square root of 2 times the square root of 2 is 2, but I have a 2 here in the denominator, so that's going to cancel. 4 times 3 is 12. So the area of the largest rectangle that can be inscribed in this ellipse, that area is 12 square units.